So let's have a look at question number 2 of review exercise 16 of math D2. So this is already given in dot diagram. So we have to solve. So how many sweets do most children eat in a week? So so we have to see which one is highest frequency. So it's 4. So this is most sweets children eat in a week. So most of the children eat 4 sweets. So this most common thing is called mode. Fine. So what is the greatest number of sweets the children eat in a week? So max value. So some children eat 6 sweets in a week. So that's the max value. So find the fraction of children who do not eat sweets in a week. So who do not sweets? So it's zeros. So how many children do not eat sweets? 1, 2, 3, 4. 4 out of, so out of total. So total we are not given. So we have to count how many students are there. So 4, let's write down here. So total students are total altogether. 4 plus 3 plus how many students eat 3? 1, 2, 3, 4, 5. So 4 plus 3 plus 5. And how many students eat 4? That most number of students eat 4 sweets in any day. Sorry, in any week. 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 9 plus 5 for 5, there are 2. For 6, there is 2. So plus 2 plus 2. So total number of students are 4 plus 3, 7 plus 5. So this is a running total. 7 plus 5, 12 plus 9, 21 plus 2, 23 plus 2, 25. So how many students do not eat sweets at all? We have to calculate it in its percentage. Do not eat sweets. So in percentage, right? In percent. So we put like that. So 4 over 25 into 100. So always when we have fraction, simplify as much as we can before doing any arithmetic operations like multiplication or division. So we can see 100 is divided by 25. So it is 4 times 25 is 100. We get 4 into 4 equal to 16, right? So 16%, don't forget this percentage sign. So we get 16% of the students who do not eat sweets at all during the week. So let's move on to question number 3. So over here, we are given a table, some lengths in centimeter of some metal rods in a factory. So we have to represent it using stem and leaf diagram. So in stem and leaf diagram, we need to define stem and then associate leaves with it. So over here, we see most of our lengths are in a range of like 140s, some is like in 130, 150, 160. So we can define our stem as 130, 140, 150, and 160. I don't see any in 170s or 120s. So let's draw stem and associate leaves with it. So over here, we have got our stem on the left side and we have got leaves on the right side. So whenever we draw stem and leaf diagram, we need to give key for stem and leaf diagram. So first I draw it, then I put the key over here. So how it is going to be like 130. So we put stem over here, 13, 14, 13 for 130, 30s, 14 is for 140s, 150s, and 160s. So when we give an example in the key. So if we have like 14 and a bar over here, and any number, suppose 5. So it means 145 centimeter. You see, our stem could be on the right side or it could be in the left side. When we draw a two-sided stem leaf, then stem is in the middle and we have a right side leaf, series of leaves, and on the left side also we have series of leaves. So we have to define for both kind of stem leaf tables. Over here, we have only one-sided, so stem and leaf. So we have to define like 14, 5, it means 145. So if we define something different, for example, I put it in different ink with the blue. So if we define like key 14 bar 5 means in some kind of different problems, it could be 14.5, right? So that become a different stem and leaf diagram, stem and leaf data. It could be, so it is important to define this key so we understand what is data we have got. It could be like 14 and 5. So it could mean like 14 times 10 raised per 5. It's like huge amount, like 14 and then 5 zeros in front of it. So that would be a different kind of data. So whatever is like having stem leaf table for different keys, we may have same stem and leaf table, but how it is interpreted, so it's based on our key. So over here, our key is this. So I erase which are not relevant to us. So our key is 14 bar 5 means 145. So if I write down 1, 3, and then 0, so that means it's 130. So which data we have got? So it is important when we make stem and leaf diagram, all data should be sorted. In the beginning, we don't know whether which data points we are going to have. So first we make it unsorted and then we sort for each stem. So let's record all the stem and leaf numbers and then we will sort them. So in the beginning, we keep on crossing when we are going to have 146. So we put over here 6. 130, 30. So we put 0 here. 0 should be in the beginning. So it's already sorted. 158. 1, 5, and 8. 165, so 16, 116 in fact, and 5. 133, so we put 3 over here. 153, 3 comes here. 145, so 5 comes here. For 140 and 5. 151, 1, 132, so here it's 2. And 145. It's important to keep on crossing so you will not miss anything or you will not add anything twice. Right now it's not sorted. At the end, we are going to sort these. 150, 130, 130, 0 comes here. 145, so we put 5 over here. 152, so let's put 2 over here. 147, so 147, 7 comes here. So it looks like 140s numbers and 140s are most frequent. 165, 131, 1 comes here, 146 like this, and 141 over here. So now we have got small groups, a group of 130s, a group of 140s, a group of 150s, and a group of 160s. It's good idea to sort them. Usually on the paper, we erase them or we create a new table and we can sort them. I can erase them, but I guess the best way is if I redraw it. So like to avoid any kind of confusion. So over here, we have got stem and leaf. I quickly put them again. So this is stem, this is leaf. Now I'm going to put them in order. Stem, we have 4 stems. And so this is 0, 3, 2, 0, 1. So it should be 0, 0, 1, 2, 3. When we have data, so we can sort them, we can put in different orders, so it will not make much difference. So over here we have got 1, 1, 2 times there is 1. Then we have 3 5s, so I put 5, 5, 5. I've got 2 6s, and there's 1 7. For 150, so there is 0, 1, 0, 1, 2, 3, 8. Let me put it 0, 1, 2, 3, and 8. And then there are 165, so I put 5, 5. So now all data is sorted. When data is sorted, it's much easier to interpret it. We can easily find its mode, we can easily find its medians. So part 1 is done. So we have represented our stem and leaf diagram. So the next one is, what is the length of the longest metal rod? So it is already sorted. So now it's easier to see. The longest is the last one. So this is going to be 16 and we put 5 with it. So 160 and 5. So longest one is 165. Don't forget the units, centimeter. So what is the most common length? So what is the most common length? It is already sorted. So we can see which length is repeated most number of times. Is it 130? It appears 2 times. No, we have got 145. It appears 3 number of times. 146 appear 2 times and 165 appear 2 times. So the winner is 145. So we call it mode. Most common or most frequent. So this value is called mode. Mode is 145 centimeter. It's most occurrence of this length. The last one is find the ratio of the number of metal rods that are shorter than 146. When it is shorter than 146, so we should not include 146. What numbers are below 146? We have to count those. And then there is another thing, shorter than 146 and that are at least 152 centimeter long. So we are counting the lower parts and the upper parts. So those rods whose length is more than 152, we have to count at least 152. So it also include 152. We have to be careful when we have to include something or exclude something, because in percentage, so it will make a big difference. So first we count those numbers which are shorter. I drop 10. I should put it back over here. It is. So first let's look at, so usually we write down L less than 146. So how many rods whose length is less than 146? Let's count them. So it's going to be from 130 up till 145. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 rods whose length is less than 146. And how many rods have lengths more than 150 centimeter? At least, so it's greater than and equal to 152. So if we don't include it, so it will create an error. We have to count everything which is included. So this is 152, 153, 158, 123, and 4 and 5. So there are 5 rods whose length is greater than or equal to 152. So in this problem, we are interested all those rods which are shorter than 146 centimeter and greater than or equal to 152 centimeter. So total rods in which we are interested. So total, we should say like total rods of our interest, rods we want, something like this. So this is 10 plus 5 is equal to 15. Out of all these rods, so how many readings we have got? We can calculate either from stem leaf diagram or we can calculate directly from our main table. So there are like how many entries? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 into 2. So 10 into 2, we have got total 20 rods. So 15 is how much percentage is 20? It is obvious it's going to be 75%. So how we 3/4. So 15 over 20 multiplied by 100. I would recommend don't multiply 15 by 100 directly. We see like it is divisible by 20, this 100. So first divide it. So we get 15 times 5. It's now easier to multiply, get the final answer 75. We have got 75%. So 75% of the rods are shorter than 146 or greater than 152 centimeter. So that was question number 2 of review exercise.